Let's start refraction of light. As we all know that light travels in a straight line in a transparent medium such as air, but whenever it passes through a different mediums such as water, it changes direction at the boundary between the two, and that is it is bent. So whenever a light comes to a boundary between two different mediums, that light bent toward the denser medium. So that is called refraction of light. The bending of light when it passes from one material called a medium to another is called refraction. So bending of light from one material to another is called refraction. So this is the phenomena of refraction of light. It causes effects such as the coin trick. The term is used in connection with refraction as shown in figure 3.221. So here we have in figure A, a ray of light is coming toward a glass slab, and from here the light enters into the glass slab. So this is normal, which is perpendicular to this surface, and the ray of light enters into the medium. Since glass is a denser medium, so this ray of light will not move like this, but it will bend toward the normal. So this angle I is greater than this angle R. This is angle of incidence and this is angle of refraction. So this is refraction angle, and when it enters into the lighter medium again, then this heavy medium to the lighter medium, then it's moved away. When a denser medium is enter into a lighter medium, then it moves away. So this is the way the refraction occurs in a glass. But whenever a light enters into a normal position, it directly passes through, because the angle of incidence is 0 degree, so refraction will be 0 as well. So it will pass through directly. So the perpendicular to the boundary between two medium is called the normal. The angle of incidence I is the angle between the incident ray and the normal. Similarly, the angle of refraction is the angle between the refracted ray and the normal. So this is angle of incidence between normal and incident ray, and this is normal, and this is refraction ray. So this angle is called refracted angle, and this is incident angle. Angle of incidence, angle of refraction. And some facts about the refraction: the ray of light is bent toward the normal when it enters an optically denser medium at an angle. So at an angle it is enter into a denser medium, so it will bend toward the normal. It bent. If it passes directly, then it should move like this, but since it is entering into a denser medium, so it will bend. Rather, it's bent to this position. So at an angle, for example, from air to glass in figure 3.21, so the angle of refraction is smaller than the angle of incidence. So the angle of R is smaller than this angle of I. This angle is larger and this is smaller. Second, the ray of light is bent away from the normal when it enters an optically less dense medium, for example, from glass to air. So when this ray enters into a lighter medium, from denser to lighter, it bends away. So this from normal to away position. So this is facts about the refraction. This is the second facts. And the ray emerging from a parallel side block is parallel to the ray entering, but is displaced sideways like the ray in figure 3.221a. So here this is the incident ray, and it bends toward the normal in a denser medium, and when it moves away, this is again move away from the normal. So if we extrapolate this to this position and this extrapolate, then these two lines are parallel. So these two lines are parallel. This is also a fact about this refraction. This is in the third part. A ray emerging from a parallel side block is parallel to the ray entering, but is displaced sideways when the ray is figure this. So similarly, if another ray is coming at this point and this will again, so this similar parallel on this side and this side, similarly it can also be in a parallel angle, parallel rays. And the last fourth part, a ray traveling along the normal direction at a boundary is not refracted. It happens in this one. This one is not refracted. This is also a fact about the refraction. This is the practical setup for this refraction, and here we have a shielded lights ray, and this is slits, and this is entering at this angle, and we can make different angles to different refraction angles, and we can perform this kind of experiment with a different incident angle and different refraction angles. So this is some precautions are there. Take care of the filament lamp, and shield will get hot when it is used. So this is one of the precautions, safety precautions. And baki rather some precautions that has to be taken for performing this kind of experiment or this practical work, so that we get more accurate results. Now this real application of refraction. So here a real and an apparent depth. So suppose we have an object here at this point. So this object will appear at the dense lighter medium. This is water and this is air, and one observer is watching this object at this point. But since this at the surface it bent away from the normal position, so it looked like that this object is available here. So if the object is at the bottom of the tank, this tank or this reservoir, if the object is placed at the bottom, but due to this refraction phenomena, since this object will appear at here, so apparently look like that the object is placed at this position. So that the depth of this reservoir will apparent as this much depth, while the real depth is this one. So this is because of a refraction phenomena. It will appear like this. So this is figure 3.23, and the phenomena of refraction can be understood through this real application. A pool of water appears shallower than it is. So this pool of water will appear shallower, this much depth. It will appear like this much depth, but the depth of the pool is more. The actual depth of the water is this. On entering the eye, they appear to come from a point I that is above hole. Rather than looking this, it will appear that the depth of this pool is this much only. So the apparent depth of pool is less than its real depth. This is because of the phenomena of refraction. Similarly, the ray when the submerged part of the pencil is in figure are refracted at water surface. So this is at the water surface it will like this. So rather than this, it will bend like this. Actually the pencil is at this depth, but due to this refraction it will look like this, it will bend. So refractive index, light is refracted because its speed changes when it enters another medium. So speed of light changes from one medium to another. In a light, air or vacuum, light travels at this much speed, 3 into 10 to the power 8 meters per second, or 300,000 kilometers per second, which is equals to 3 into 10 to the power 8 meters per second. In a glass, its speed falls to 2 into 10 to the power 8 meters per second. So we define the refractive index as the ratio of the sine of the angle of incidence to the sine of the angle of refraction. So refractive index is defined as refractive index N is defined as sine I incident angle and sine R refracted angle. So angle of sine angle of incident and sine angle of refraction. So greater the refractive index of the medium, the more the light it bends. If refractive index is more, that means the bending of the light is more and more. So the change in the direction of travel of light when its speed changes on entering another medium suggests that light may also be a type of wave motion. So refraction phenomena at speed of changes, it also suggests that light is also having a wave motion. So light also shows a type of wave motion because of this refraction phenomena. In the next session we will learn some numericals or practice question on this refractive topic, refractive of refraction or refractive index.